Radhe Radhe. So in this video, I'm going to discuss the peaks in array problem which occurred today's LeetCode challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. Problem statement is very simple. You're given an array and you're given some queries. So if you're seeing a 2, that means you have to update the specific element. And if you are seeing something like 1, so you have to find the, like, you have to append it to the array. Okay, so what the update is, the update is at position, at a certain position you have to insert something. Okay, so that is, so let us take this example, or maybe let us take this example because 2 to 4, so that is 4 is 4, so we don't take this example. So let's take this example. So 0 1 2 3, 0 1 2 3, so this position becomes 4, right, after the first update. Now for 0 to 4, so 0 1 2 3 4, that is the whole array. How many peaks are there? There are no peak. Okay, so if you look into the array, there is no element such that the element previous to it and the element after it is lesser than that. Okay, so there are no peaks, so it becomes 0. For this 2 to 4, so this becomes rewritten as 4 only. So if we check for 0 comma 2, that is 0 comma 2, this thing 4 1 4, no peak is there. But if we make it till over here, so there is one peak, that is this 4, because it is greater than this and this. Okay, now simple approach, you have to use a segment tree. Okay, segment tree. Now remember one thing, whenever you are using a segment tree, it basically does what? It basically runs queries, updates the values. So these are the two main things. Okay, there are a lot of operations other than this also, so these are the two main things. So how the update works? The update works in a very simple pattern. Okay, so that is, if at any position, okay, so let's say there were 3 elements, you're going to update B. Okay, now let's say there were 3 elements, so B was already a peak. Now if you're going to update B with some other element D, and if D is greater than equal to A and D is greater than equal to C, sorry, D is greater than A and D is greater than C, so what you can say, that there is no change in it. Okay, so there is going to be no change in it. But if D is greater than A but lesser than C, so what happens? It basically gives an opportunity for C to become a peak, and it takes away its own value. Okay, so basically if C becomes a peak, so the peak gets transferred from here to here, and let's say if D is lesser than both of them, so it gives opportunity C as well as A to become a peak. Okay, so basically it's at every update it is either going to be +1 +1, -1 -1, or +0 -0. Okay, so if you go into the details of it, so once you're done with the update, so you know that from this element to this element the peak lies over here. Okay, now how we are going to, so this is the update is for this 2. Okay, now for 1, when you are going to run the queries, so how we are going to run it? So let's say for 0 to 2, so 4 1 4 2 1 5. Okay, so 4 1 4 2 1 5. Now if you look into this matter very carefully, since we are dealing with only the peak elements, so if we are going to consider from this element to this element, this is already a peak because this is greater than this, but this is greater than this. But since in this position you have to just find for 0 1 2, so you can't consider this because this element, these elements can't be considered. Okay, so that is the reason it was 0 not 1, but 4 is a peak element. Okay, but since we are getting access till the second position, so we can't make this 4 as a peak element. How we are going to manage it? So let's say initially what we were doing, we can make answer dot append query sorry, what was it? Queries of I of 1 and queries of I of 2, right? This is initially what we could have done, but this won't work for here. Okay, so over here what we are going to find is, we have to find the minimum of queries I1, query I2, and then query. Okay, so this is segment query. Okay, like just in order to make it more clear, so segment query of queries I1 plus 1 comma query I2. Okay, and then segment query of query I1 and query I2 minus 1. I'll let you know why we are going to do this. Okay, and segment query of queue of I1 plus 1 queue of I2 minus 1. Okay, so we have to find the minimum of all these four. And remember one thing, if we find that this is any one of them, if implementing plus 1 or minus 1, if it becomes out of bound for the array, we don't need to consider it. Okay, very simple. So why we are going to do this? Because if this is a 4 and this is already a peak element, but remember one thing, whenever you are going to take this into consideration, you can't take this element and this element. Okay, so now a more modified version of this will be, just make it segment queue of queue I1 plus 1 queue I2 minus 1, because you're not going to consider this, so from plus 1 and this minus 1, so you're going to consider only 1. Okay, similarly for this 414215, okay, 414215, so whenever we are going to consider for 41 this thing, you're not going to consider this 4 and not going to consider this 1, so you're going to consider only this much, it is 142, so there is only one peak element over here. Clear? So that is how this one comes. So that is the reason why just this append of this portion won't work for this. So if that's clear for you, I think that's it from my side. Thank you.